Hey dosers, welcome back to another video. Today we are going to be focusing on, you guessed it, how did you know, graph transformations. So let's get right into today's video. So over here I've listed in this slide at least all of the transformations that are possible, at least the basic ones that you need to know for now. And I just want you to pause the video and quickly go through this. Just read it through and try to remember it throughout the video, as I will be going through each and every one of these transformations here in today's video. So just pause the video and go through it. Alright, now let's move on. So first we're going to be tackling vertical translations. So translations means movement. Yes, movement. That is not a stretch, not a stretch, and not a compression. That is what a translation means. That means if you have a graph like this, it stays the same. It's in its geometry, it just moves up or down. This is the vertical translation. The graph can move up and down, and it can be seen in this graph too. So this is the original graph, f of x. F of x minus 2 means this just moves down here. The overall shape is the same. It has not been stretched or compressed. It just moves it down 2. But for this one, if f of x plus 1, I know it's a little bit hard to see. Let me try enlarging this real quick. Yeah, there we go. So in this one, f of x minus 2, it just moves f of x down 2 units. But in f of x plus 1, it adds 1 unit. And you have to remember, if it's f of x plus a, right, it has to be outside the function. So let's say you have a function which is x plus 2. F of x is equal to x plus 2, right, in brackets. If this, x plus 2 to the power of 2, yes? And then you want to transform this function. Let's say they ask you the question, f of x plus 2 is what you want, right? So you can put it inside the brackets. You cannot put it with the x over here. You have to put it outside. You have to put the 2 outside. I hope that makes sense. Now that's simple enough. Let's move on to horizontal shifts. So horizontal translations is the same as vertical translations, but with a minor change. So in vertical translations, it was relatively simple. You just add a to the y coordinate. Sorry, I should have gone through this. So x comma y of f of x turns into, let's say, f of x plus 2 again, right? It goes to x comma y plus 2. So you basically just add whatever your a is to your y coordinate. That's all you do, right? But in horizontal translations and horizontal movements up and down, right and left, what you have to do is that the horizontal translation will be given inside. So f of x minus h in this case over here. So minus h over here means that it will be added, since it's moving right or left, something will be added to the x coordinate, not to the y coordinate. So if it's f of x minus h, in the case of horizontal translations, the minus indicate positive. So that means that if it's a negative value, it shifts right. So negative means shift right, but positive means it shifts left. That's what it means. I know this is a little bit confusing. I'm gonna write it down in a different way. So if it's f of x minus h, right? If it's minus h, it goes x plus h comma y. That is how the horizontal translation changes. But if it's f of x plus h over here, right? If this is how they've given you your function, your updated function, it becomes x minus h comma y. Yes? Great. Now let's move on. So reflections across the axis. So this is not considered a translation. This is a transformation still. All of these are transformations. But in this case, it's reflection across the x-axis and y-axis. And we'll be going through that now. So minus f of x. When the minus is outside the function, not to the x, it is to the overall function. So minus bracket f of x. That is basically what it's saying. It is not saying, in this case, we'll go through that later. So it's saying this entire thing. So when the function is like this, it means that there is a reflection across the x-axis. Or what you can do here is multiply the y coordinates by minus 1. So it's x comma minus y. That is your transformation. For your reflection across the y-axis, right, it's f, but it's only specifically to the to the x. So this minus is only specific to the x. So in this case, it's a reflection across the y-axis as seen in this graph over here, right? It's reflecting across the y-axis. It's reflecting this graph across the y-axis, and that leads to the x-coordinate being multiplied by -1, which means negative x comma y is how you would update your coordinates of each coordinate of your original function. Let's move on. So vertical stretch and compression. So in this graph over here, we have our original function, which is f of x is equal to x to the power of 2. So this is our original function over here. This one over here. Yeah, the blue one. Yes? So what happened here is that f of x was multiplied by 3. So it went 3 times f of x. That's what happened over here. And again, this is applied to the overall function, not specifically to the x, the overall function. Yes? So that means that this vertical stretch increases the values of y. So since this can be considered to y, your values that will be updated is x comma 3 times y. That is how you'd update your coordinates. And if it was a small value, like let's say this was 1/3, so it was 1/3 times f of x instead of 3, it would just be x comma 1/3 times y. Vertical translations are very simple. No matter what the value is, all you have to do is multiply it by y. Like 3 multiplied by y. When it's a vertical translation, all you have to do is add it to your y value, as seen over here, y plus 2, for example. So vertical translations are very, very easy. It's the horizontal translations, remember this now, the horizontal translations that you do the exact opposite. So now let's go through that over here. So once again, it's f of x is given as your original function, your red function this time. So f of x, and this time you're multiplying 2. But this time it's specific to the x, as it is in every single horizontal stretch, compression, or transformation. But in this case, what you do is that sure you still multiply to the x, but in this case, since it's 2, what you do is you don't multiply directly by 2, you don't multiply your coordinate, your original x coordinate by 2, you do x over 2, comma y. And this would mean that it's a horizontal compression. But if instead it was not 2, it was 1 x over 2, so 1/2, x being multiplied by 1/2, it would be 2x comma y. And this is because what you have to do over here is you have to do x divided by 1 over 2, which is 2x. So that's what you plug in here. So remember, it's the exact opposite for horizontal stretches, compressions, or vertical or translations. So I just want you to keep that in mind as a really, really important note. And now finally we've come back to our rules, and hopefully we've gone through everything that you need to know for the basics of horizontal translations and graph transformations. So I have posted in these Canva slides a challenge question for you to attempt, and the answers are posted on the next slide. So please do go through that in your own time and try to solve it, and hopefully you should be able to do it. And if you still need additional help, there is a link in the description below the Canva link, which is a link to tutoring sessions with me, a one-on-one tutoring session with me that you can book completely for free if you need any extra help. So do let me know in the comments if there's anything else you need me to go through. And thank you for watching today's video. See you later, dosers.